everyone. Today's topic of discussion is how to delete a node from a single linked list given its position. So as we know, a linked list is a linear data structure which is a series of connected nodes where each node is connected through these pointers. So for a single linked list, each node have this two things. One is a value which basically stores the data of the node, and another one is the next pointer which basically points to the address of this next node. And this is the first node is called the head through which we access the linked list, and the last node points to basically null because there is nothing after this last node. So let's say what we have given is, we have given a position, let's say for our case it is 2, and we have to delete the node from position 2. So this is our position 1, this is 2 and this is 3. So if we just check visually what to do if we have to delete this node. So if this node is not supposed to exist, what we can simply do, we can take the previous node, and this previous node can just point to this node, and so this node doesn't exist in this linked list anymore and our job is done. So what we can do, we can take two node. This is a current node which is basically the node that should be deleted, and the previous node which is just the previous node of the current node. And what we can write is, for the previous node, the previous of next point to current next. So this previous of next point to current next, and that is done. So how we can reach this previous and current position? Our position is given, so we will just iterate through a loop that while our position is not equals to 1, what we will do, the previous is equal to current and the current will be the next node, because we are iterating through the linked list. So current next and the position minus minus. So what will happen, we'll start from a particular position until we reach the position equal to 1. We'll iterate. The current will go one step further and the previous will have the position of current. So when we'll reach position 1, current should be at that particular position and previous is just before that, and then we can do previous next equal to current next, and that is our main code. Now let's say there is some edge cases. Obviously there will be some edge cases. So what if our position is given as 1, not any value, 1. So when position is 1, this won't work because the previous or current is starting from the head, right? When we are iterating, the previous should be at our head, same as the current. We are beginning from the head and we are iterating. Now when the position is 1, so we have to delete the head. So the next node, the second node, should be the head. So this is simply just one line we can add. If our position equals to 1, what will happen? The head should be the head next. So we have changed our head. So now instead of this is our head, and that is done. We'll start from this point. Okay, so this is done. Position equal to head next, or else we can do this block of code. Now there is another edge cases. What if the position that is given, that is more than the length of the linked list? For, let's say for this linked list we are given a position of 5. That can be the case. So there is nothing at position 5. So basically we don't have to modify the list at all. So for this thing, this code won't work. Why? When we're going to this block, basically when this is 5, the current is at a null position. When we have reached in this block at position 4, current is here. Now after the next iteration, where will the current will go? Current equal to current next. Current is already null. So this will throw an error if the position is 5. So for that, what we can just modify, that don't iterate this block when there is nothing in current. So we have to just add this condition at this while loop, while position not equal to 1 and our current exists. That is current not equal to null. Only then you go through this code. So what will happen if position equal to 5? After a certain point, when we reach this current equal to null, we'll simply go out of this block and we'll add another line over here, that when current equal to null, you cannot go by this line. So before this line, just add if our current exists. If our current not equals to null, only then you run this block. That is done. And what can be another edge cases? Let's say we don't have a linked list at all. That is, our head is empty. So we can just add this at the first line. If our head equals to null, then just don't do anything. Just see out that this is an empty list. And that's all. You can just return after this. Return 0. And that is done. That is the whole code. So this is how we are doing when we are given a position and we have to delete it from the head. Now similarly we can do another thing. Let's say we are given the value of a node, like if the value is 2 or 3, we have to delete that node. In the similar manner we can go, just instead of this we have to check at each, instead of putting this position condition, we can just put that when our current value is equal to that particular given value, then just delete that node, rest of the code will be same. So that's all.